All right, here we have another density problem. This time it's Venus. Uh, shouldn't be very surprised. At any rate, let's. So we have the mass in kilograms. The radius is in kilometers, and they ask us the density in grams per cubic centimeter. All right. So just as a reminder, I'll do this over here on the side. The density, which is given the symbol rho, is the mass divided by the volume. The mass has to actually be in grams. All right. This is all right. So anyhow, here's the mass of Venus. Um, it's 4.87, and it's times 10 to the 24th kilograms. Just replace the k by times 10 to the 3rd, 10 to the 24th times 10 you just add add 3 to that. All right, so that becomes times 10 to the 27th. All right, so e 27. All right. I guess I should show you that just to be sure. Anyhow, that's grams. All right. So where does that come from? That is 4.87 times 10 to the 24th. And of course that's kilograms. And then you say, all right, well, in 1 kilogram there are 10 to the 3rd grams. All right. So 10 to the 24th and multiplied by 10 to the 3rd, you just add the exponents, right? And so that's all you're doing. All right. Yeah. So that's all right. Anyhow, all right. So we're going to do that, and we'll do that in our calculator in just a second. All right. So the more difficult one is R. All right. So we got to change R from kilometers to centimeters. All right. And you can always here. I'll just write this down. 1 kilometer is the equivalent of 10 to the 5th centimeters. All right. So if you just use that conversion, and you could do it in 2 steps just by saying 1 kilometer is, 1,000 meters, and 1 meter is 100 centimeters. That's how you get the 10 to the 5th. All right. Anyway, so you just you write the same number, which I did not do. That okay. That meant to be a 6. Sorry. 6051.8. Right. So, and if I want to directly change it from kilometers to centimeters, I just put in the times 10 to the 5th. All right. And so now it's in centimeters. All right. So that's that. So now I use this number. Remember, this first number is a 6. I just didn't write that correctly. All right, so now the other thing that we have to do is we have to calculate the volume, right? And this is a planet. Most things in astronomy are spherical, just because of self-gravitation. If it's large enough to self-gravitate, it always self-gravitates into a sphere. So it's going to be 4 times pi divided by 3 times the radius 6. So that looks better. 6051.8 times 10 to the 5th. It's supposed to be to the 5th. All right. And then you raise that to the 3rd power. All right. So that'll put it in cubic centimeters. All right. All right. So I got the scientific calculator. So there's the 6051.8, and then we got to do times 10 to the 5th, and then raise it to the 3rd power, and then multiply it by 4 pi times 4 times pi, and then divide by 3. All right, All right. All right. So there's our answer. Let's see. Oh man, this calculator. All right. Let's see. When I originally counted this, I counted the decimals wrong, but so this turns out to be 9 point, roughly 9.28, and this is in the calculator. That's the unrounded version, times 10 to the 26th. All right. So here, let me prove that to you. If I divide this number that's in my calculator, well, it is. It definitely is. All right, so I'm going to use that. I'm just going to store that just for the heck of it, just to keep it in here. All right, so just let me show you that this is true. If I divide by 1 times 10 to the 26th, that should give me 9.28, and all the other digits as well, right? So there it is, right? So, all right, let's clear that. All right, and then we go back to we go back to our mass in grams. So the mass in grams was 4.87 times 10 to the 27th, right? EXP 27. All right. And remember, I just stored the volume in cubic centimeters. All right. So divided by the volume, which is right here, I just hit this memory recall. And then, that's that 9.28 times 10 to the 26th in scientific notation. But remember, what you want to do is you divide the numbers unrounded and then round at the very end. All right, so this is the density of Venus, and they tell us to round it to one place past the decimal. So it's going to be 5.2, and the digit after the 2 is a 4, so I don't round up. All right, so the density of Venus, so the density of Venus is about 5.4, which is actually roughly the density of Mercury as well, by the way. And it's, of course, grams per centimeter cubed. Hold on, how did I get? Hold on, I must have done something wrong. Let me see. Oh, 5.2. I didn't mean to say 5. I don't know why I said 5.4. In the calculator, it comes out to be 5.2. Sorry about that. I messed that up. Sorry. All right, so this is going to be 5.2. All right. I thought I had done something wrong, but I didn't. All right, so let's do the next one. Number 9 is very similar. All right, so looks like number 9 is not quite as similar. I thought it was another density problem. All right, so it is actually looking for the surface gravity. So the surface, of course, we're talking about the distance, from the center of the planet to the surface. That's of course going to be the radius of the planet. They give us the radius. They give us the mass. That's really all you need. All right. The mass has to be in kilograms, and it already is. So that's fine. The radius, however, has to be in meters. All right. So for Mercury, it's 2,439.7. All right, and again, it's kilometers. So you just do this. You say, well, in 1 kilometer, there are 10 to the third meters, right? And the kilometer part cancels, and so that becomes the exact same number, but now times 10 to the 3rd. All right, so here we go. Here's the surface gravity. All right, so I called this in the formula sheet A sub G, and so that's equal to big G times the mass. I'll just put the letters for right now, divided by the radius, or really the distance from the center of the planet to where you're looking for the surface gravity, but you have to square that, and R has to be in meters. All right, so now we can put the numbers in and do the calculation. All right, so I've written all the numbers over here for our formula for the surface gravity. All right, so anyhow, let's get our calculator out and let's delete that one. All right, we'll start again. Okay, so to do this, here, let me, actually, I'll leave this over here so you can see it. All right, so here we go. All right, so 6.67 times 10 to the minus 11th. All right, and then times 3 point. So the mass of Mercury, which is 3.3 times 10 to the 23rd, exp to the 23rd, divided by, all right, and so this is the radius of Mercury times 10 to the third, but remember, we got to square that, all right, so it's going to be divided by 2439.7, and of course that's times 10 to the third, and then we square that, right? Right, and so this is going to give us, just as a reminder, the surface gravity of the Earth is 9.8 meters per second squared. All right, so this, the value for let's see, what did I do wrong here? Hold on, let me try this again. All right, well, it looks like I must have I messed up on the solution. So I just paused the video and tried this again. So the actual answer, just to let everybody know, is, now it says to round it to one place past the decimal. So so the answer should be, see, it says in the calculator it's 3.69, since the second digit past the decimal is greater than 5. This rounds to 3.7. 3.7. And the answer is in, of course, meters per second squared. So this should not be 3.4. This should be 3.7. I'll correct this on the on the sheet. So you probably won't notice that until you actually watch this video. But anyhow, the correct answer is 3.7.